Welcome to the video for tutorial 6. We are firstly looking at exercises similar to the procedure exercises, and we are starting with the exercises under section 1.2, number 20. It says, determine whether the angle between U and V is a right angle. So that is very straightforward. All we have to do to know whether it's a right angle is we have to know whether U and V are orthogonal, so we have to work out the dot product. If the dot product is 0, then they are orthogonal. So I'm going to say U dot V is going to be 2 multiplied by 1 plus 3 multiplied by minus 1 plus minus 1 multiplied by 1, which is going to give us 2 minus 3 minus 1, which gives us minus 2, which is not 0. So, no, it is not a right angle. Number 30 says, let A be the point minus 3, 2, B the point 1, 0, and C the point 4, 6. Prove that triangle ABC is a right angle to triangle. Right, so what I'm just going to do is I'm just going to draw the 3 points wherever. So this is A with coordinates minus 3, 2. This is B with coordinates 1, 0. And this is C with coordinates 4, 6. And then I'm just going to draw a triangle. So what we need to do is we need to show that one of these angles, this one, or this one, or this one is 90 degrees, because then it's a right angled triangle. How can you do that? Right? So for working out whether the one in green is a right angle, you can say, let's take this vector's dot product with this vector to see if it gives us 0. So in other words, that's going to be CA dot CB. To see whether the purple angle is a right angle, you're going to take this vector's dot product with this vector's dot product. So in other words, that is going to be BA dot BC. And finally, for our red angle, we are going to work out the dot product between these two vectors. So it's going to be AC dot AB. Right. So when we work out those dot products, for instance, if we look at AC dot AB first, we are going to have C's coordinates minus A's coordinates. So it's going to be 4 minus minus 3 and 6 minus 2 dot, and then we have B's coordinates minus A's coordinates. So it's going to be 1 minus minus 3, and then it's going to be 0 minus 2. So that gives us 7 and 4 dot 4 minus 2, which gives us 7 multiplied by 4 plus 4 multiplied by minus 2, which gives us 28 minus 8, which is 20, which is not 0. So therefore, that angle is not a right angle. Next, if we look at BA dot BC, we are going to have, I'm just going to write it up here, the coordinates of A minus the coordinates of B, so it's minus 3 minus 1, 2 minus 0, dot AB, dot BC, which is the coordinates of C minus the coordinates of B. So that gives us minus 4, 2, dot 3, 6, which gives us minus 4 times 3 plus 2 times 6, which is indeed 0. Therefore, we know that one is a right angle. I'm not going to work out the remaining angle, but you can test that one and you'll see that it's also not a right angle. The next problem is under section 1.3 and it's number 11. It says find the vector equation of the line passing through the points P and Q. So in order to find our vector equation, we need two things. We need a point on the line and we also need a direction vector, because the vector form looks like this: x equals P plus TD. Since P and Q are both on the line, we know that a vector going from P to Q or from Q to P will also be on the line. I'm just going to let D be the vector going from P to Q, but you could also use Q to P. That doesn't matter because those two vectors are scalar multiples of each other. In this case, they are just, the one is just the negative of the other. So it's then going to be the coordinates of Q, which is 3, 0, minus the coordinates of P, which is minus 1, minus 2. And then we have 2, 2. So that is our direction vector. Then for our point, we have P, which has components 1 and minus 2. If you wanted, you could also use Q with components 3 and 0. So I'm just going to use P. So then I have xy equals 1 minus 2 plus t multiplied by 2, 2. You could also use, as I said, Q, which is 3, 0. That will also be correct. So this is the end of the procedure exercises.